They might not be able to pull you out of a freezing lake or carry you from a burning building, but plants have probably saved your life. Or at least made you feel a whole lot better. That's because, at least in the US, a quarter of all prescription drugs come from substances that are found only in plants. We humans have a long history of using plants to treat diseases. Most of those treatments were probably discovered using blind luck, like by people just munching on random leaves and seeing how they felt. If they found one that seemed to do something, the knowledge would usually get passed around by word of mouth, but sometimes it would also be written down. That's how we ended up with recipes that are about as old as writing itself, like the 5,000-year-old Sumerian clay slab that lists 250 plants for preparing medicines. Of course, the recipes don't always work, and there are plenty of old herbal remedies that do absolutely nothing, but a few did work, and we still use some of them in medicines today. Many of the plant-based substances people use belong to a broad group of bitter-tasting, nitrogen-containing compounds called alkaloids. These compounds don't seem to be strictly necessary for plants to survive, so they probably offer evolutionary bonuses, like a defense against anything that tries taking a bite out of it. Their names usually end in INE, and you've probably heard of some of them, like caffeine, nicotine, morphine, and a lot of them have effects on our bodies that are pretty strong, for better or worse. Take the deadly nightshade, for example. In 2009, a woman was hospitalized from eating just 6 nightshade berries, which she thought were blueberries. 10 berries could have been fatal. One of the killer compounds in nightshade is atropine, an alkaloid found all over the plant. But atropine also has a good side. It's actually on the World Health Organization's model list of essential medicines in 3 separate places. Surgeons can use it as a sedative for short operations or to dilate the pupils to gain easy access to the back of the eye. And despite being extracted from a plant so toxic, atropine works as an antidote against certain types of poisoning. Some pesticides and nerve gases overwork the parasympathetic nervous system, and atropine can counter that deadly effect by blocking the receptors these toxins overactivate. Other useful plant-based drugs took a lot of hard science to make work, as in the case of the anti-malarial drug called artemisinin. The compound comes from the sweet wormwood plant, and Yu Tu, the chemical engineer who developed it, was awarded half of the Nobel Prize for Medicine in 2015. Using plants to treat malaria is not a new thing. The disease has probably killed half of all humans from the Stone Age to today, and we haven't beaten it yet. With so many people suffering, especially in developing countries, it's not surprising people turned to plants for a cure. Around the world, more than 1,200 plant species are used to treat malaria and the fever that comes with it, but only a fraction of these have been properly tested for their effectiveness. One of the first remedies known to be genuinely effective was quinine, an alkaloid that comes from the bark of Peruvian cinchona trees. A compound known as chloroquine, which was based on quinine, was later developed synthetically as a safer and more potent version of the drug, but it wasn't long before the Plasmodium parasite that causes malaria started showing resistance to chloroquine, so people started looking for an alternative. Tu and her team turned to traditional remedies from China. They scoured thousands of traditional recipes for potions and medicines that were said to reduce fever, looking for the most promising plants. They found a clear winner. One plant, the sweet wormwood, showed up in not just 1 or 2, but hundreds of different recipes. Initial tests of sweet wormwood extracts on the malaria parasite were promising, but inconsistent. Some experiments showed sweet wormwood to be highly effective, but others only slightly. Tu thought the variations might be caused by differences in the way the wormwood extract was prepared, so she went back to the old texts to find more clues. Most of the remedies suggested processing dried leaves with boiling water, but Chinese philosopher Ge Heng, writing in the year 340 CE, had a different suggestion. He described a preparation process that used fresh, not dried leaves, and involved extracting the juice by soaking those fresh leaves in cold water, wringing them out, and drinking the juice straight down. Based on this account, the team developed their own extraction method using ether and then tested it out on mice, monkeys, and finally people. And it worked! The new and improved extract killed off malaria parasites soon after they entered the host's red blood cells, and with relatively mild side effects. The active compound was called artemisinin after the plant it was found in. The discovery of artemisinin created a whole new family of anti-malarial drugs that are still used used to treat malaria today. Then there's diabetes, another disease that people have been trying to treat for a long time. Uncontrolled blood sugar levels in people with diabetes can lead to complications like nerve damage, sight problems, and kidney failure. But plants have our backs on this one too. For the estimated 400 million people who have type 2 diabetes, one of the most widely prescribed treatments is metformin, a relatively simple molecule that's made up of just a few nitrogen, carbon, and hydrogen atoms. The story of metformin starts with an herb known as goat's rue, or professor weed. It stands over a meter high with white, blue, or purple flowers. Professor weed has been used to manage diabetes around the Middle East and Europe since the Middle Ages. In the late 1800s, studies found that the plant contained high levels of an alkaloid called guanidine. When isolated, guanidine worked great at reducing blood sugar levels in animals, but it was too toxic to use in people. So chemists got to work trying different adaptations of guanidine that kept blood sugar down, but without the whole poisoning problem. The result was metformin. Safe, effective, and cheap to make, metformin is helping millions of people manage their diabetes. Despite its simple chemical structure and plenty of research, we still don't know how metformin lowers blood sugar or why it's so effective with so few side effects. So what thanks to the American people give this life-saving plant? We slap it on the noxious federal weed list. But to be fair, that's because it's an invasive species in the US. It's a lot less destructive when it grows in the Middle East, Europe, and Asia. Not all plants are so common though. In fact, plants containing the secrets to much-needed cures may have gone extinct before we had the chance to even name them, let alone study them. And we've come close to losing life-saving plants before. In 1987, for example, a botanist named John Burley trekked through a swamp forest in Malaysia, collecting plant samples to study back in the lab. His travels were part of a larger mission to find new treatments for various cancers as well as HIV. One of these samples, tagged Burley and Lee 351, didn't kill cancer cells, but it did do an amazing job of preventing HIV from replicating. So the collectors hightailed it back to the forest, only to find it gone, cut down for firewood or building. Extracts from similar trees didn't have the same effect because they were slightly different species. It was only salvaged when a few trees of the right species were found at the Singapore Botanical Gardens. The drug is called calanolide A, and it's currently in phase 2 clinical trials and owned by the local Malaysian government. Then there's this pretty little thing, the rosy periwinkle. It might look like something that would be right at home in my backyard, but it's actually native only to Madagascar, though it will happily grow anywhere warm. The native people of Madagascar use these periwinkle plants for all kinds of ailments. In the 1950s, researchers from Western pharmaceutical companies studied the periwinkle and discovered that it contained some rather remarkable alkaloids. Two of these, called vincristine and vinblastine, are used to treat certain types of cancer by stopping the cells from dividing. Vincristine has helped increase success rates in treating kids with leukemia from just 10% in the 1960s to well over 80% today. And vinblastine is often a core chemotherapy component for lymphoma, a cancer of the lymphatic system, as well as testicular cancer. All kinds of plants have amazing substances locked away inside of them, so the next time you walk past a tree or flower, give it a pat on the leaf, assuming it's not thorny or poisonous to the touch. Anything like that. You might look a little strange, and the plant won't understand, but it probably deserves it anyway. Thanks for watching this episode of SciShow, which was brought to you by our patrons on Patreon. If you want to help support the show, you can go to patreon.com/scishow, and if you just want to keep getting smarter with us, you can go to youtube.com/scishow and subscribe.
Where did these adaptations come from? And why would a plant need to eat meat when it gets its energy from the sun for free? Well, while most plants get their nitrogen and nutrients from soil through their roots,